All right, let's do some Boolean algebra. Here we have an expression x, y. I'm going to OR that with x, y naught. How do I approach this? All right, let's take x out of this entire expression. And this is how we'll do it. X comes over to here. I'm going to multiply it times y. This will give me xy. Bring down the OR. And now, x times what will give me this? I know. Y naught. X times y naught will give me xy naught. Beautiful. Now, what do I do with this? I have x, and then I have a y or a y naught. Well, what does that mean? Here's a OR gate. Whoops, that was a bad OR gate. Here's an OR gate. And you have y and y naught. So if y is 1, y naught will be 0. If y is 0, y naught will be a 1. If you have a 1 or a 0, if you have a 1, let's make this look nice. If you have a 1 or a 0 on an OR gate, you're going to get a 1 for an output. If you have a 0 or a 1, you're going to get a 1. If this is 1 or a 1 on this 1 or a 1 on an OR gate, you're going to get a 1 output. So I can reduce this whole thing, y or y naught, to a 1. This becomes 1. And x, now we say x times 1. What does that mean? That means you have an AND gate, and you have x on it, and you have a 1 on the other one. Well, 1 and a 1 will give you a 1 output. That's the only time you get a 1 that's an output. So, problem, I don't know what's in x. So, what if x, so let's imagine. If x is 1, and we have a 1 here, and x is 1, then you have a 1 and a 1, that's going to give you a 1. If x is 0, you AND that with a 1. 0 and 1, you're going to get a 0. So, whatever x is, that's what your output's going to be. So, x ANDed with a 1 always gives you x. Always. So, we've taken this whole expression and reduced it to x. Wow. So, x and y, or x and y naught, equals x. Is that what we did? Yes, that's exactly what we did. Wow, that was fun. Well, thanks so much for listening. This is George Boole. Bye-bye.